Okay, please start.
All
Yuchen.
right. All right. So the paper that I'm presenting today is called Revelio, ML-generated debugging queries for distributed systems. And these are the authors. So we have Pradeep Doga, who is a PhD student in UCLA, and his research interest is in networking systems and NLP. And we'll see that come into play in the paper later on. Yep. And then I think he's supervised by Dr. Kartik Narasimhan and Dr. Anirudh. Yeah. Right.
Okay,
So
these researchers are not that familiar with that. But anyway, so nowadays, given the computer system or the computer science is developing very rapidly, so a lot of interdisciplinary research are emerging. So it's good for us to check and combine, not only focus on traditional AI or traditional software engineering. So basically, we need to combine both networking systems, AI, software engineering, even HCI. We need to expand our investigation so that we can have more new ideas there. Okay, Yuchen, please go on.
and another three authors. So we have Shiv Kumar Sani. I think he's a senior research scientist at Adobe Research, and I think he is the person who helps them apply their tool into production applications. And then we also have Dr. George Vajis, the Chancellor Professor at UCLA, and Dr. Ravi Nathralvali, who is an Assistant Professor in Princeton. Yeah, so I think most of them have a research interest in computer networks. Yeah. Okay, so let's go into the paper itself. The background is about this debugging distributed systems. So in the case that they are investigating, the developers need to take in user reports and system logs. And then from these two, they have to determine a query to query like a monitoring program. So this monitoring program serves to basically trace the goings in a distributed system. And then by issuing a query to this monitoring program, they are able to determine which subsystem is at fault for a given bug. Yeah. So actually, the paper itself doesn't really target like which line in the program is a problem. It only narrows down the scope to a subsystem.
Basically, from the ideal point of view, they're the same. Just to narrow down the place where the fault may lies. So here, you can consider the logs is actually the trace, right? But the system logs actually means the different events happens on the whole systems. And maybe we can see more into it. But I think the more important, or for me, the most interesting part is that how to get you the query. So that is just like if we want to understand some things, it is very important that we're asking the right question, right? It means that we have the right direction to go. So is there any, do you have any recommendations or any technique for generating the queries, or just rely on the user to propose the query?
Yeah, so we'll go into that. I think one of the limitations is that they cannot come up with their own queries. So okay, so I'll go into that when we come across. Yeah. Okay, so this is basically the taxonomy of the kind of bugs that a developer might face in a distributed system. And then we can see here that they categorize it into these few root causes. And a small number of the bugs make up a large majority of the tickets. So you see like component failures and subsystem source code bugs, they make up close to like 90% of all the different tickets. Yeah, and then even though the recurring faults are like they are the same kind of bugs, but then they are at different locations. which makes the debugging time very high, an average of 8 hours. Yeah, even though they are quite similar. Okay, so this is the solution that they come up with. It's called Revelio, and it is a two-phase query. It's not, two-phase query generation ML model. So what happens is that they take in the system logs and the user report, and then they split the process into two parts. So the first part will generate a template for the query, and then it takes in, so the second part will take in the template as well as the system logs to populate the values for that template. And then finally, this query is given to the developer to execute.
So basically, that is a way to generate a query, right? So from your workflow here, so the input is a system log and user report, and the output is a generated query.
Yeah, but my problem is that the template, right, is part of the data set, so they cannot generate a new template that is out of data.
I think that is okay because there's a way for the template. So MLI means machine learning. What does I means?
Oh, this is one. So they have two models.
Machine learning 1 and machine learning 2. So they're using the first machine learning models to select a template, and then they combine the template and system log to generate a query. And this process is iterative because if we want to locate one root cause, maybe one query may not be enough. So consider about this, that the debugging is more like information reduction. And the way of debugging is basically a way of reduce the information entropy of the whole system, right? Each time we ask the questions, we want to remove a set of possibilities, right? So in this case, but that means one queries may not enough to remove the majority of the possibilities. And we may need to keep asking questions, remove possibilities, and then ask another questions, remove another part of possibilities, and we iterate this process until we locate the bug. And then in these procedures, is it iterative or is it just one-shot approach?
Yeah, so this approach is more one-shot. I think what the end state is that you have issue a query, right? And then from the results of the query, so you maybe have a list of subsystems. Then from there, the developer will figure out which one is the error, the one with the error.
Okay.
I think yeah. So that's an interpretation. All right. So okay. So these are some examples. So by query, I mean that it is some kind of it's some kind of query language, right? So in this case, it's the SQL. So we have select something from something, yeah, and then the template will have blanks, and then the blanks are this underlined dashes, and then these underscores will be populated later on. Yep. And then the user report is like a natural text kind of bug report. And then the system log is so open tracing and maple log.
So that means the system log have to actually form or follows a schema, right?
Yeah. So it's a certain format. Yeah, so it's more structured. Okay, so this is basically the architecture. So what happens is that the user report is run through a BERT deep learning model, a neural net, right? And then it is encoded into a vector form. And then similarly, the logs are also encoded into a vector form with
And what does FFN means?
I think it's forward feedback net or something like that.
Okay.
Yeah, I'm actually not super sure because they only
I can
mention.
see they're using multiple deep learning model, right? So using FFN, BERT, graph convolution network, and another. So it is quite a network system, right?
Yeah.
Okay.
So these two forms it's turned into another vector that encapsulates the user report and the system state together. So this is what the vector is for, and then the template is transformed into an abstract syntax tree form, and then this is passed into the graph convolutional network to once again generate a vector form, and then it creates a template likelihood. So this one will calculate the probability, the probability of using this template in a given situation, whether it's high or low. And then from there, the template is fed into this second system, and the logs are also fed in over here to another neural network to generate the possible parameters. Yeah, so is there any questions so far?
I have no further questions, but I just doubt whether the template is the number of templates is large enough. And since I'm no expert in the so-called debugging template, so maybe I'm going to rephrase your point. The first is that given a user report and the logs, the system first to select the most likely used template to use. So basically, when a bug happens, we always need a query. So that is assumption of this approach. But what kind of the query template we're going to use, right? Some template are going to search for some information, and some template propose to search the other information. So basically, we're going to calculate some kind of similarity or likelihood for each template to see how likely we're going to use one template to address this issue. And after we select template layers and we further combine such a template and the log information, right? We use log information to select which slot in the template should be filled in what parameters or values there. The flow is quite clear here, but it will be more helpful if you can provide a concrete examples so that we can remove some of the possibilities of my imagination.
Okay. The paper didn't really give like
intermediate
examples, but I think we have some like end examples I can show you later.
Okay, sure.
Okay, so right, so this is the formalized model. Okay, so basically we are trying to induce a probability from the data. So given R is the user reports and L is the logs, we want to find a query to fit this situation, right? So this query can be split into the two subtasks, which is to find a template and then to find the values of the template. And so we can factorize it like this. And then the paper makes an independence assumption on R. So the user report will not be helpful to find the value U to fit into the blank. Yeah. So this is it. And then this is what happens. So this is like basically a repeat of the architecture diagram. So GCN takes in the template, and then if I'm not wrong, it creates a vector representation for every node in the abstract syntax tree. So we take the vector representation for the root of that AST, and then BERT gives us the vector representation for the user report. Then this linear network gives us the vector representation for the logs. So VR and VL are concatenated together and then pass through ReLU and then pass through the linear network to create this vector for the state of the distributed system. So I believe there's a typo here where the VT is used. I don't think the VT is included. It's supposed to be included here.
Yeah. Let me think about it. So here VT is just a template, right?
Yep.
So VS actually represents how likely this template can be used for this report and this log. All right.
I think this is more just an encoding task. So this is just turning
Okay.
the R and L into
Okay,
another
so your
vector.
point is that VT should not be used here. Is that, am I understanding correctly?
Yep, yep.
Okay, so yeah, I think that is the archive version. So one of the drawbacks of the archive is that the paper may still have some typos or it has not been fully formalized. They just want to claim an idea. Okay, please go on.
Mm. Yep. And then so finally it's so concat the state and the template together in order to generate this value, I guess. And then we softmax it to get a probability. Yeah. And then the objective function here is to maximize the probabilities of choosing T or given the state R and L.
Okay, let's keep going on.
Yeah. Okay, so in the second part, this is predicting the values to fill in. So what happens here is that we take the blank index of that AST. So recall that the AST, each node has its own vector. So we choose the vector representing the blank. And then we pass it in together with the, this is the logs. Okay, so LU, what happens in LU is that the logs are separated into their subsystem. So it's grouped by subsystem. And then from the subsystem, they extract certain features. For example, like if it's a switch, then it can be the queue depth of the switch. So like how many packets is it holding in a given time? Things like that.
So wait, so you actually means the user report, am I correct?
No, U here refers to subsystem.
The subsystem. And but
Yeah.
this is the log of subsystem, right?
Yep, the log.
So log of the subsystem. But anyway, if we want to fit into a neural network model, their dimension need to be fixed anyway, right?
Yeah, I mean that this is the vector after extracting the features.
Okay.
Yeah.
And also I may need to raise a question is that here, if we want to fill into the parameters inside the template, it's not a classification model. It is basically a generative model, right? That means we need to generate something, right? So
What do you mean by that?
So here, if I understand correctly, your template is basically a CQ, the CQ like why is missing. So let me try it again. So basically, it is more like a CQ, right? Right? Why my writings will be cleaned and why will be cleaned there?
Oh, I'm able to see. Can you try again?
Okay. So it will be removed, and it will be removed anyway. So anyway, so maybe I can use my speaking my I just speak that. So when we have a template, it is basically an AST. When we have AST, basically some node there or some leaf node in the AST is missing, right? So the task here is that we're going to fill into the missing leaf node in the AST template. Am I right?
Yes.
And so this task is basically a generative model, a generative task, because we need to generate the leaf node there. And in this case, why it is, but for me, it looks very much like a classification problem. Am I right?
Yeah.
So how to fill the gap about it? Because we have a generation, we have a need to generating, a need of generating the leaf node on AST. But here, how to fill in the gap between the information generation and the information classification?
I think that I think that, okay, so the classification part is in the first model where
Yeah, we have already classified which template to use. So that is fairly clear. But once we got the template, how do we generate the leaf node on the template?
yeah, so it's just taking in the logs and then training data to decide a possible subsystem to choose. The phrasing that they use is a bit weird. So sometimes they call it value, sometimes they call it like the subsystem. So I'm thinking that they are choosing like
So
a ID.
here, yeah, and here, what's the relation between the query and a subsystem?
The query and the subsystem.
Yeah, and here, so maybe I can further ask the questions that when the template, after we crystallize a template, and basically the template is actually a SQL-like query language, right? Just basically a query there. So what's the outcome, or what's the result, or what's the return result of the query?
The return of the query actually depends on the system, the debugging tool that they are using.
And can you raise an example and what will be returned?
Okay, so let me show an example. So it's stuff like this. So it can look like a SQL query, and then you can see the blank here is by ID, for example. And then, but there's also different kind of queries, like it can be this kind where the query language is more proprietary. And then they are populating.
And for example, because I'm familiar with the CQs, but I'm not sure the filters and group wise, so they're still a little bit fuzzy to me. But for the first and second one, it's going to select the span, right? The span, and the span just basically one value, right? And once we got this value, how does this value can help us to further narrow down where the bug or where the root cause in the whole distributed system?
I think that there's still a lot of like user like processing that needs to go on after this. So in this case, I think they are saying that the user needs to look for comments where the connection has failed error. And then you can see the subsystems that throw this error, and then they realize that, oh, actually they are trying to draw from memcache. That's why the connection failed, and therefore the problem is with memcache. So I feel
I think here I understand. So if we want to get the whole pictures, we need to spend a lot of effort, especially you because you are the presenter. You may need to spend a lot of effort there. But I think for us, I think they're so just based on their technique, they're not, frankly speaking, that is not so novel to me, given their approach design. But what I really care is about their problem definitions, right? So what kind of a query it is, and what kind of log it is, and why the template be there will be used for. And as long as we understand the rationale there, and we can have more understanding of the how distributed system work and debugging or how they can be debugged. Yeah, so maybe why I choosing a paper as distributed system. The reason is that nowadays the people are, especially researchers, are more and more focused on the real world system. And the real world system usually both concurrent and distributed. And in the future, even for deep learning models, there will be some kind of federal learnings. That means training a model will be distributed in the future, especially in some big companies. And how can we, because we need to foresee the future. For now, we just debugging the traditional software on a single machine with single threaded program. And then even for focusing on Xianglin's work, this is we assume that the model is trained on a single machine. But what if the training happens in the distributed systems, and how do we address that kind of problem? So that's why we were looking to the distributed systems from time to time here. So I think compared to this program design, the approach design, we focus more on the problem definitions and what is the most important problems in these areas. So that is very important. So when you understand, you just focus on this paper, but I think it's better if we can have a more deep understanding of the problem, what the problem looks like. So that'll be more helpful. Once we got the problem, or once we ask the right questions, I think it does not matter whether their approach is how they approach the design, because we can design our own approach, maybe even better, right?
Yeah, so okay, I can clarify on their reasoning, because I feel that they also didn't go into details on like why the query is important, but basically the reasoning was that they only have the user reports and the system logs, right? And then from there they need to narrow down, they need to do investigation to narrow down the kind of subsystems and the problems. So the
And they also
the
had
solution here,
assumption. They also had assumption that they have a list of templates, and the only solutions can only select from a limited set of template. Is that a realistic assumption there?
yeah, so they rationalize it by saying that since that a lot of them are repeated, so and then all the repeated bugs will have to use the same kind of template. Yeah, so that's why they structured the whole model like
Okay,
this.
okay, let's keep going on. I think also this is basically an AI for system or AI for SE paper. So once the problem is just there, we can define a lot of the models and techniques, AI techniques to address this one. Maybe I do not linger on how they address the generative models here. My follow-up question is that how can they train the model, and whether there is a sufficient data to train a model there, and they're using the GCNs, using the deep neural network model here, and they have to be collected, right? They have to collect a large number of data, a large number of queries, and how they collect those data.
Yeah, so they worked with a company that is anonymous, and then they basically look through all the tickets between a few months, and then they basically hand labeled the data.
By the way, the hand label means that each label is a template there.
Yeah,
and also each template is not just yes or no questions. What template we're going to use, how to crystallize the template. We need all that data so that we can train the task. Isn't that label intensive?
Yeah. I think that's what they did.
Okay, let's keep going, continue. And is there any questions here? If no, let's keep going on.
Yeah, okay. So one thing to note is the rank. So the rank is basically the subsystems, like each feature in the subsystem, right? So what rank are they with regard to the rest of the subsystems? And this rank is supposed to help to provide some kind of like relative information, so that the generated query is able to like generalize into different locations.
Oh, sorry, wait, Yuchen. So I need to be absent for 5 minutes. Maybe I stop recording here. Hi, Yuchen. Please go on.
Okay. Right. So last we stopped is predicting individual value for the blank. So this is given by P2 here, right? So the final probability for like the whole set of values will be the product of each of them. Yep. Okay. And then finally, we're just choosing the ones with the highest probability. Yeah, and then the output can be like top K, so it can be a few templates, and then each one have a few options. So basically, the paper chose like top 5 for the output. And then now we go into the implementation details. So basically I realized this is feed forward. So for all the feed forward layers in the ranking model, they use 2 layers each, and then the hidden size is 300. And then the GCN also has a hidden vector size of 300. And then Adam optimizer and learning rate of 0.0001. Yeah.
Okay.
So how they tested the efficacy of their tool is to basically emulate a microservice application. So they have all of this in containers running on one host machine. And then they also have switches that emulate the network. And then basically for each application and pair, they will inject a fault via the network, for example. Yeah. And then so all of them, they basically use Amazon's Mechanical Turk to test.
By the way, how they deploy the microservice? Jingyue, do you have an experience on microservice? Hello, is Jingyue there? Okay, so let's keep going on.
So they use something called container net, if I'm not wrong, but all of them are in their own Docker containers, and then they are orchestrated together with another program. Yeah. Okay. So basically they set up a feedback session for each Mechanical Turk user. They have a proper example, and then they are asked to use this application where they may or may not be issues, and then they are asked to give feedback, which is like, it can be free-form answers or it can be a multiple choice. And then they split the data into 53% for training, 13% for validation, and 34% for testing. And this testing is split into 2 more sets, which is generalize and the repeat. So for the test or repeat, it's kind of just it's actually just values inside the training set, actually, if I read the paper correctly. So this is just a test whether the learning is complete or not. And then for generalize, they are testing for out of data examples.
Sorry, Yuchen. I can take a phone from Prof. Dong. Waiting for me for 5 minutes.
Okay. Right. So basically, that's the testing methodology, and then these are the results. So actually, most of the queries that the tool outputs is close and always in the top 5. Yeah, and then you can see that about 80% of the time it's the first query that is given. And then this is the
testing. This is the testing result, right?
Yeah.
And how do they now it's a match?
So they split the data into 2, right? So
yeah, but that means if we want to, it's okay that we selected the correct template, but how, and what if suppose they have the query in the blank, they have 3 blanks and 2 blanks is correctly generated. We fill in the blank, 2 of the blank correctly, but 1 of the blank incorrectly. And how do they evaluate such a case?
Yeah, they didn't specify that, but I think it is by exact match. So it's only considered correct if it's like all the blanks are also the same. Yeah.
Okay.
So this is for repeat results, and then this is for the case of generalization. So perhaps you want like a different value in the blanks, and then it's only correct like 60% of the time, but overall it's still in the top 5. Like the correct answer is still in the top.
Okay. let's keep going on.
So actually that's all.
Okay.
Um,
Okay. So thanks, Yuchen. Here, I think maybe we may look into the publications for the published paper instead of archive in the future. And for this approach, I feel that for me, one of the takeaways is that giving the log, giving the user report, and how do we ask the right questions to narrow down the root cause, right? In this case, I just feel that the approach seems a little bit limited to me because it may not help us to fix the problems or pinpoint the root cause. It doesn't, right?
Yeah, I agree, because it seems to only do like a very specific thing. I think at best it helps to determine like which category the problem is from, but not much more than that.
Yeah, I think one of the idea coming to me is that how do we evaluate the chaos or the information chaos or the information entropy? So we know that there's something wrong happened at the end, and we know there's a root cause which is hidden somewhere else, somewhere in the program or in the model or the systems. And how do we narrow the gap and keep asking the correct questions to narrow down? So I'm not sure you have I'm not sure whether you have heard about a quiz. Is that suppose we have 12 small balls, and one of the balls is have the same appearance, have the same shape, but it will have a different weight than the others. And we have a leverage. And we can only measure those balls with the leverage for 3 times. And how many times do we need to find the balls, to find the anomaly balls? So this is a very simple quiz, but based on information theory, and it will tell us that we need the upper bound that we need at least 3 times to reach there. And for debugging problems, I think it is very similar to such information theory problems. So once we find an appearance and we want to find a root cause, and how many queries are there for us to narrow down the scope? So, and what are those queries, what kind of queries are there, or what kind of feedbacks are there for us to reduce information entropy? So that is all very important questions. And this paradigm or these routines can apply for both the software systems and the deep learning models. Okay, let's talk more later. But anyway, it's good to know about the problem paradigms of the distributed systems. And if we want to further proceed on these areas, I think a more concrete benchmark is the first thing we need to investigate. And what is the really important problems or questions we ask? What is really important research problems, and what questions we ask is the next thing we need to explore. Okay, thanks, Yuchen. Next one, how about Xianglin? Hello, Xianglin.
Yes.
Yeah, your paper is still an archive paper, right?
Yeah.
Okay.
So this paper is called "The Spotlight: A General Method for Discovering Systematic Errors in Deep Learning Models." So it hasn't been published yet, but based on the format of the paper, I think it targeted on NIPS this year.
Okay, so it's the NIPS this year means it has been under review. No, right?
I guess, but it has the format of NIPS.
Oh, I see. Using NIPS format. Okay, let's keep going on. Yes, maybe you can try NIPS in the future as well.
Yeah, so all of the authors have some connection to UBC, and their research interests are more in AI, machine learning, and behavioral game theory. So the background of this paper, first we need to introduce the systematic errors. It means the subset of the data that deep model performs poorly in. Here we have an example. It's a gender recognition task. So when you are given a face of a person, the model is going to predict whether it is a man or woman. And based on this study, the researcher found out that the vision model tend to have a higher error rate when presented with images of Black women. So the subset of Black woman face is considered as systematic errors for the vision model. Such systematic errors could have problem because first it is hard to detect in advance. So the researchers cannot tell whether there is such systematic error ahead of time.
And here it's more, it reminds me about the research of fairness testing. So the fairness. So basically, fairness is just tell us when we train a model. For example, we want to using an automated system to detect who should be admitted as a PhD student in NUS, right? So basically we just train all the admitted PhD students in NUS in the history, right? So basically we can prepare the training data and train a model here. However, we will find that the male PhD students, the number of male PhD students was much larger than the female PhD student. As a result, the model will have an inclination to say, giving a male PhD student, and he will more likely will generate a higher likelihood for him, but not for her. So this is called a fairness testing. So and also such a phenomenon happens for Black people, white people, because Black people will have less chance in the history. So in this case, and how do we detect whether the model has learned the bias in the history data? So that is one of the very, very hot topic research in recent years.
And I just continue. And the second point is that such systematic errors actually widely exist in many research areas, like object recognition, speech recognition, mortality prediction, and recruiting tools.
And this is also very similar to Dr. Xiaoyan's research. And her research basically want to analyzing and what is the unexpected input. So when we train the models, and the training data cannot always be perfect, or in the most times the training data will not be perfect, but the model can only be as good as the training data. So when the training data is not efficient or is not sufficient, and after the model is deployed, and some unexpected data or some out of the dream data come, and how can we handle such a case? Basically, Dr. Xiaoyan was trying to answer this question. I think Xianglin is also helping her in this work.
Yeah, and one potential solution or naive solution is to recognize and label well-defined groups in data set ahead of time, such that there might not be some unbalanced group. For example,
it will be very challenging.
Yeah, but the problem is it's extremely difficult to anticipate which group of data would fail. Like in the vision model we mentioned before, you don't know whether the model would perform poorly on like a particular group, like different age, post background. You just don't know that. So this paper presents spotlight it aims to detect the systematic errors in data set. And why it is called a spotlight? It's like spot is a dot, so they are trying to find a small region in the data set that the model performs poorly in. So each spotlight corresponds to one systematic error.
Okay.
And so first we can talk about the high-level idea of this paper. Since they don't, the high-level idea is quite simple. You just search for continuous high-loss region in the final representation layers. And since they don't have the visualization of final representation layers, I just grab an image from our work, DVI, to show you what the final representation layer looks like, to help you better understand the content. But here on the image, each point represents a sample from the training data set. So you just take the final representation vector from the model, and here we do some dimension reduction technique to project the high dimensional representation embeddings to 2D. If you are interested, welcome to talk to me. But here,
Here is basically just showing that how the training data are distributed in the high dimensional space.
In the final representation layers, and they aim to find a small region where the samples inside this region would have higher loss compared to other regions in the rest of the data set. And
so here, maybe we hear a question that why the systematic error? So, my question is why the systematic error will present such a feature that it will be forward on a continuous and a high loss region. Matter why?
Because you want to find a subset of data that model performs poorly in, right? Like the example we mentioned before, some Black women. So those they assume that those Black women would have some common.
And is that a training data? And
common,
will the Black woman appear in the training data?
of course, the Black woman would appear in the training data.
And that means the Black woman appear in the training data, but the model will still have.
Yeah.
So we're talking about the training inaccuracy. Or the testing inaccuracy. So the problem occurs for the training data, or
I think in general the training data set is are large, right? So if you average the loss might not seem so high, but they try to find some small region that have higher loss.
So kind of the samples which has to be sacrificed to satisfy the loss of the other samples.
Oh, sorry.
That means a part of samples which has to be sacrificed, their loss have to be sacrificed for the sake of the loss of the other samples. Do you remember that when Wang Chao is here, we're talking about a conflict sample or contradictory samples? That means given a model, if we want to satisfy, for example, if we have to satisfy the black man, white woman, and a white man, and we have to sacrifice black woman. I'm not sure whether I pick up the right point, but since the black woman, the sample of the black woman appear in the training samples, but the model have a poor performance on those samples, and there must be a reason there.
But in this paper, they didn't talk about the reason. They just try to find whether.
They just show, right? They just show that a part of sample. So basically, because when Wang Chao is with us, And we went to the experiment. I think you are still in our group. They're showing that when the model architecture is naive enough, and there must be some complicating samples, and if we want to satisfy part of a subset of the samples, we must sacrifice the other subset of samples, and unless we increase the expressiveness of the model architecture. So that is somehow, maybe that is one of the reasons, but given your explanations, black woman is part of the training samples, and the model still perform poorly on those samples, right? So in this case, I may not be correct here, but one reason come to my mind is that those samples are kind of sacrificed, right?
Maybe.
And basically, those black women samples are not noise data, right? Their label are actually correct.
Yeah,
and maybe one of the reasons is the model is not expressive enough, right?
Maybe, yeah. You are here you are talking about how to fix the problem, but in this paper, I think the main point is to identify whether they have systematic errors or not, but not any further
fix. Okay. The remedy, what I mean, or mitigation. Okay.
And yeah, and then the approach. So because here we try to find a small region where the model performs poorly in. So each region can be defined with two parameters. First is the center of the region, and then the other parameter is the shape of the region. So if you have those two parameters, you can locate one region, right? Here first we introduce a Gaussian-like parameterized kernel function for weighting samples. Sorry, Dr. Lee, you have some noise in your background.
Okay, so there's a machine striking on my window. Sorry for that. Okay, maybe you can.
Yeah, I'll try to focus. So this Gaussian-like parameterized kernel function is to put a weight on each samples. So here, as I showed here, it is so this is the kernel function. The mu the input of this kernel function is xi, represents any samples in the data set, and mu is the center of the region, and tau defines the shape of the region. So if you are given the region of if you are given the high loss region and any samples in the data set, the kernel function would return the weight importance. And the tau is a positive semi-definite precision matrix.
Tau. And
tau.
Would you please?
Tau is.
Yeah, and how does tau?
Tau is a matrix.
Yeah. A matrix, a constant, or
tau is
a function. Here is a function, or
tau is a matrix. It's a d times d matrix. Here we assume each xi has a dimension of d.
Okay.
Yeah,
so let's transfer and how, because I'm not that familiar, and how does the tau can represent the shape?
Tau is
yeah, you're just saying that
no, because like for example, if tau is a identity matrix, then the shape of the region is a sphere. Yeah, sphere. And if tau is not identity matrix, then the shape might be some elliptical.
So basically, it's going to transform or reshape, right? It's not a shape. It's trying to reshape the region. So basically, the kernel function is trying to it's return the weights, right?
Wait, yeah.
Giving
so,
a sample and giving the region is going to evaluate how important this
Yeah.
sample is to this region, right?
Yeah.
Okay.
Not the region, but how important xi
It's away from.
yeah, it's away from the center of the region. So here I have a question. What is the range of kernel function? This kernel function.
Okay, it's good. That's a good question. Okay. So maybe you can
Hey, 若凡.
0 to infinity.
So tau is a semi-definite matrix, right? So what is the range of this part? Just this part.
zero, right? So it's more.
So for any semi-definite matrix, let's say A, it has a property that any vector xt times A times x is larger than 0. So this is the property of any semi-definite matrix.
So 0 to 1.
Yeah. So yeah, that's correct.
Okay.
So this kernel function, I think it measures the similarity between xi and mu, and if
And also will be normalized between 0 and 1.
0 to 1, yeah. So if xi is close to the center mu, then the k would be close to 1, right? And if xi is away from the center of that region, then this kernel function will return a value that is close to 0. So that's what this kernel function is doing.
Okay.
Yeah. So basically, the mu controls the position of the center, and tau controls the shape of high loss region. And yeah, and last point, if tau is equal to a identity matrix, then the region is spherical, otherwise elliptical. And then
I have a question, Xianglin. Back to the previous page. The last line said if tau equals alpha times I.
I is identity matrix.
So it's. Oh, I know. It's basically a matrix form of alpha, right?
Oh yeah. So alpha is any hyperparameter.
Yeah. So if alpha is, if tau equals alpha, the region is spherical. You mean?
Sorry, if tau equals alpha.
You mean if tau is larger? So this is a relatively spherical shape. Otherwise, it's a narrower shape.
No, I mean if tau is any identity matrix times alpha, then it's spherical. Otherwise, if it's not a identity matrix, then it would be.
I know. Okay.
Yeah. And then they turn this finding the region to be an optimization problem. Here is how they do it. First, they try to maximize the importance weighting times loss. So if you remember that we are saying it tries to find any continuous high loss region. So Li basically controls the loss. It tries to focus on any continuous high loss region, and the weighting part, it means we only look at a small region. When you look at this weighting parameter, I think about, it reminds me a lot of the Tisney formula. Like let me like this Ki represents how similar between the sample Xi with the center of the, and then the denominator part is just a scaling factor to like normalize it to be, I think, to be 0 to 1. So when you look at this formula, this is the Tisney similarity measurement, and you look at the numerator. If tau equals to identity matrix, then they are basically the same, right?
On here, the J is the centroid, right?
The Xi is the centroid.
Sorry, Xi is the centroid. So basically,
if tau is any like alpha times identity matrix,
I think the tau really matter. So whether the shape really matters. So when we understand when we try to understand here, what maybe the tau here, the shape matters. But anyway, let's look at it. Let's look at the tau. The tau there.
I think they are exactly the same. The kernel
except the Tisney will have a scaling sigma.
But here we have alpha, right? Alpha can be the sigma I. Right? They are the same.
Okay.
Except here alpha, you might need to look at the best alpha.
I got it. Okay.
So I think that also explains why the Tisney performs so well in the nearest neighbor preserving property, because it only look at the small region around any sample X. But anyway, I just think they look a lot similar. And then the constraint, the sum of Ki needs to be larger than some predefined value S. That means they try to control the size of the region. It couldn't be too small, because if the sum of Ki are too small, that means any Xi in the data set is not close to the centroid. So that means you might only look at some outliners instead of some region. So the constraint just control the size of the region. It needs to be at least larger than some predefined value. And then they just turn this problem as an optimization problem to find the best mu and tau. Because here the parameter we are searching for is the center mu and the matrix tau.
Okay.
Yeah.
So here, there's another point is that okay, the region here is basically controlled by this S, right? This S is more like the radius to me. Right? More considered the radius. So that means that we need to find a mu, and within the region, under a radius, and all is included samples in that region. Suppose you have a high loss, high loss, and let me think about the scaling effect. The scaling effect means that and can you further explain the scaling effect here? So that means the one closer to the centroid, it is better to have the high loss, right? Okay, that makes sense. Okay, it still makes sense to me. I think I think Xianglin explained this in a fairly clear way, and I hope everyone here can understand this slide here. Is there anyone have a question here? Okay, if there's no question here, let's continue.
Yeah, and then after you define this problem, the next step is to search for optima. But in practice, they found that because the feasible region is non-convex, so it's very difficult to find the mu and tau. And in their experiment, they found that
And there's two parameters, right? So the search is going to
mu and
optimize,
tau.
only optimize mu and tau. In this case, if there's two parameters in the search, I don't know. The search is supposed to be okay, right? It will not be so complicated because we just need to optimize only two parameters.
But mu is a d-dimensional vector and tau is a d times d matrix. All right.
So, but in this case, total number of parameters d times d squared, right?
Yeah.
It is still not a large number.
But the searching space is large, I guess.
Large?
Because for those d plus d squared parameters,
right. So in this case, the number of the weights for mu is d, and the weights for tau is d squared, and the supposed dimension is 100, and it's still kind of not so okay. Let's see. So still maybe 10 more than 10K.
But anyway, in this test, they said that they found that the optima tend to lie close to the constraint. That means sum of ki equals to s. And what they did is they add penalty term as they move closer to the constraint. I guess they try to search the best inside the interior of data set instead of around the constraint.
Wait, so the constraints means
the constraint means
the weights or the cutoff.
The sum of the ki equals to s. That means.
In that case, we may just consider this an optimization. I don't know. Xianglin will go back to the previous slides. I don't know whether we can combine these two cases. Suppose this equation 1, and this equation 2, and then we can equation 1 plus lambda equation 2, and then we optimize the whole function here. In this case, we can also control the radius, right? I don't know. Maybe that's the way.
Anyway, but they just add a penalty term as they move closer to the constraint, and the outcome is that they say they improve the optimization of spotlight.
Okay.
Yeah. And then the second problem is you don't surely after you don't just find one spotlight and then terminate. You will want to find multiple spotlight in the data set. And how did I do it is first, after they found, let's say they found one spotlight in the case round, and then they update the loss of the data set. Basically, they just decrease the loss inside the spotlight found in case round, and then continue to find the next one in the k+1 round.
So this is an iterative process.
Yeah. And this formula, it just if xi is close to the center mu, then the loss would be decreased a lot.
Okay.
So they do this process iteratively, and I think this process is quite close to the expectation maximization algorithm. If you are interested, you can also check that algorithm.
Well, it is close to the.
It just reminds me of the EM algorithm.
Yeah, but EM algorithm is going to set a template, a probability template, and then we try to maximize.
Because it has multiple Gaussian models, and
both EM and this approach use Gaussian models, but the EM approach can using a lot of the other probability distributions, right? May not be Gaussians, it could be ballooning, right? Or could be the other power distribution. Yeah, I just feel a bit different. There's still a difference there. Okay.
Yeah, but anyway, the third problem is to search for tau. And as you mentioned before, in practice, they found that if they let tau to be any semi-definite matrix in practice, they couldn't find meaningful spot slides. And then instead, they set tau to be C times identity matrix. So in this case, they only have one parameter to optimize.
Yeah, then the optimization becomes even simpler.
Yeah, and in this way, I think the formula of the kernel function is exactly the same as t-SNE. Yeah. Maybe they don't even need to search for C. They can just use
let it be one,
sigma.
right? Just let it be one, or may not.
Sigma I, like, I'm not sure, but the results are better and faster to optimize. And they didn't give an explanation on why the results are better. Yeah, so that's all. The approach are quite simple, I think.
Yeah, so maybe I can make a comment here. So the idea is fairly straightforward, right? They just want to find a continuous region where majority or all of the samples in this region have a high, more like a normal detection. What I think so, just like in these areas. For the other areas, and there are loss functions for up and downs, and have an average of the low. And when we find a region, it has a lot of it has a higher error density, then we just report it, right? So for our approach, we may not using such a measurement. Then they invent a measurement or a search query, basically just a query, right? The optimization basically is a query to search for such a sub-range or multiple sub-range for that. But for us, if we have the visualization, maybe because we still have the neighbor predicting property.
Do you think is it possible? Because, for example, we draw a heat map based on the loss values, and maybe in this way we can also find some spotlight, like
exactly. So if we can first we visualize it, and then we highlighting it with maybe red dots, so those samples with the wrong prediction. And then basically, I think we do not need to do this, right? As long as we find a subset of the range, while the dots actually located in the other region, right? But let me write it here. So suppose these are classification boundaries, and the red one supposing red regions, and maybe the blue one supposing the blue region, right? And suppose this is blue regions, and this is red regions. As long as we find a red regions, which is a small region is lies here, then we just achieve what they have done, right? So that is
let me think about it. But high loss doesn't mean though. In this case, the red samples needs to be classified as blue, but in their case, it only has high loss. That means those red samples might distribute it in other
in the region. Maybe, what I mean is that maybe in this area, the region samples on this area. But for this area, we just say it is vulnerable. But actually, when we train the model, we are more interested in this case, right? Yeah, I think for now, a lot of measurements or a lot of technique are applied to find this anomaly. But how to find the anomaly? And I think our approach answers a mental question. So how do we find an anomaly? We are search what we know, but whether there's something unknown in the whole search space, which can raise more interesting questions. I think the DBI framework is going to answer this kind of question. But let's see whether this approach can be accepted in the NIPS. Yes, they can accept it. It's good news for us.
I think in their paper, I don't know, I'm not sure because the approach section, it only consists of one page in their paper. In the previous slides, I add a lot of my own interpretation to it, but in their paper they only spent one page, and it seems quite simple actually.
Okay.
But they did a lot of experiments because they claim that Spotlight is model agnostic. It only needs the final representations and loss of each input. So it can be applied in many tasks like image classification problem or NLP, the sentiment,
supposed to be,
sentiment analysis or question answering, or even recommendation systems. So in their experiment part, they cover all those tasks. So the first one is the gender recognition task. So it needs to, the model needs to give prediction on whether the image is a man or a woman. On the left, they present some random samples of the data, and then they highlight some samples with highest losses. And based on our human interpretation, we cannot see the similarity between those high loss images. But on the right is their results. So the first spotlight, they found that those images all contains like side views. You only can see half of the face of the person. And the second spotlight, they found that the images they are all discolored or have grayscale. And in the third spotlight, they all contain the face of young children. So that gives the researchers an explanation on why those data have high loss, because those labels like discolored images, they don't have a label.
They don't have a label. But how do, if they don't have a label, how do they?
But I mean, no, I don't. I mean, they don't have a label as discolored. They have a label.
Okay, I got it. They have label of gender, but they do not say. Okay, so they. But anyway, I just feel that those examples are involve some human interpretation.
So they after you know the region, they involve human to interpret the result.
Okay.
And then the second example is the classification problem of ImageNet. Again, on the left, we have some random samples and highest losses sample. And on the right is the result. So the first spotlight, they all involve people in the image. So maybe, I don't know, the network cannot perform well. And the second spotlight, they all contain some cluttered
I think this is not a very strong evaluation. They involve too subjective human interpretation here.
Yeah, they don't have quantitative results. Most of the experiment results are qualitative.
Yeah, in this case, how can it be get accepted? Okay, I mean that's not our problem. But anyway, it's good for us to know this.
and the third spotlight, they all have a background like forest. I don't know.
Okay.
And then in the question answering data set, here I need to mention because each token or each word has 768 dimensions, and they try to form a single representation for each question or each sentence. So they just concatenated all hidden vector to produce 3 million dimensions for one question, and then random project it to 1,000 dimensions.
I have a question here. So the length of the questions is different, right? So
but they just random projected to 1,000 dimension. The 1,000 is predefined.
I understand the 1,000 dimensions is fixed, but here I just wanted the technical solution here, and for each question, I think definitely the question will be of different lengths. So for one sentence, suppose you have over 7,000 dimensions, and the sentence suppose you have 1 million. Suppose I just have a exactly right the length here, and since after concatenations, the length will be different, and how the random production is conducted.
Yeah, this part I'm not sure because they didn't mention that.
Yeah, and at least they may just average all the dimensions. That might be a very brute or naive solutions. And if they're using some using some BERT models, which they can use in CRS to fix the dimensions. There have a lot of the technique to fix the dimensions or have a representative vector for one sentence, regardless of its sentence length. Okay, but whatever, we can keep going on.
Yeah, and based on the results, I think some spotlights or the model performs worse when the words contain some technical words of computer network, like packet switching or
I don't know. Here, I think when they figure out the spotlight, it can be anything. And now the authors trying to summarize or manually interpret the commonalities of each spotlight, saying that they do the interpretation. I think if they want a paper, they have to do this, but I'm not sure how meaningful this action will be.
And then there is also sentiment analysis, and
by the way, I understand the sentiment analysis. They will do something similar there, and if I'm the one, I probably will randomly inject some. Basically, they're trying to report debugging samples, right? To try to slice us. So I do remember that we once reported another paper, which is from Sigmoid, just to search for a set of samples, which may be responsible more for the bug. And here they are doing the same. So if that is the case, I probably just inject and mutate or inject a set of the labels or add some noise label here. So in this case, just to see whether those noise data will be figured out, right? So, but anyway, so different researchers were using different experiment and evaluation to do this. But anyway, so and also I think a follow-up empirical studies will be necessary. So whether in the real world training such a continuous region exists, and how likely it will be exist, and what is the more fundamental reasons. Because for this work, it's only saying that a continuous region of training samples cannot be predicted well. And is that really the problem of the data samples? Or maybe it is also the problem of model design, right? So I think more insight for discussion and interpretations might also needed for this in this work.
Yeah, but I just think it's more like a identify a problem instead of
Yeah, you're right. Identify the problem, propose a measurement for the query, and then search the data based on that query, and that's all.
yeah, and yeah, how to solve this problem is another problem. Yeah. And then for the recommendation system, this task is given the movie name, the type of the movie, and the reviews, and the model is going to predict the rating, people's rating of that movie. And then in their result, they found that the model performs bad on some 3 to 4 star action comedy films, or one particular film, or or some
Okay.
So they just find the similarity between any spotlight samples.
Okay, let's keep those false interpretations and keep going on. I think if the experiment just be the same, let's keep those slides and look into a more informative one.
One interesting thing is they give the result of X-ray chest, but they claim that due to the lack of expertise in medical area, they were unable to discuss area.
Yeah, because they cannot make up more explanation.
Yeah, they cannot tell the similar. Yeah.
Okay.
And yeah, that's basically all for this paper, and they propose some future directions for spotlight. Yeah.
Okay. I think one way to do this is to follow is that whether anyway they raise something interesting, but this interesting, I'm thinking about whether those interesting point will be a trivial point if equipped with our DBI technique. So once the DBI technique will just be there, because both DBI and their approach working on the gap layer or the last representation layer there. So and if that is the case, maybe our visualization tools will just visualize such a anomaly. No need to search for that.
Yeah. I think so. So maybe later I can spend some time to generate a heat map and see whether we have spotlights as well.
Sure. That's great.
Yeah. So that's all for the presentation.
So thanks, Xianglin and Yuchen. I think both make very good presentations, especially when we have your own interpretation and understanding, and that is how we extract something from the paper. So we read the paper, understand the paper, criticize the paper, and improve the data out. I think that is that will be a very benign and good route to keep going on. Is there any questions here? If there's no questions, let's thank the speakers and call it a day. Bye.